Okay, welcome back. Am I audible?
Yes, sir.
Yes, sir.
Okay, right. So today in this session we will talk about Floyd, Warshall, all pairs shortest path algorithm. In the previous algorithm called Dijkstra algorithm, you have a shortest path only from a single source. In this case, we will look into the shortest path from the perspective of all the nodes. For example, from 1 to 4, 1 to 2, and 1 to 3, what is the shortest path? From 4 to 1, 4 to 3, and 4 to 2, what is the shortest path? If there is any path or there is any alternative path which has a shortest path. It's not like single source. So we cannot start from 1 and say that we want to only go from 1 via 2 to 4 or 3 or something. But we should get something like from 1 to the all other nodes, what is the shortest path? From 2 to all the other nodes, what is the shortest path? And that is the reason we have this name, all pairs shortest path algorithm. And this is also called Floyd Warshall algorithm. So the Dijkstra's algorithm is a single pair shortest, single nodes shortest path to the other nodes. But this is all pairs. So all nodes to all other nodes. Let us see how we can do it. The first thing is we can construct a small adjacency matrix to represent this graph. So let us see how many are there. So we have 1, 2, 3, 4. This also 1, 2, 3, and 4. Let us now write for each one what we actually have. The same thing we follow. If there is anything that is direct connection, we do write the weight here. Or if there is no direct connection, we have an infinite. 1 to 1 should be 0. The reason is that there is no looping. So this is not there. If this is there, that means 1 to 1 is also here. So there is no loop and hence I keep it 0. And most part, my diagonals are all 0. So 2, 3, and 4. So these are all 0 because there is no loop among the nodes. The node cannot approach itself. Now tell me 1 to 2. Is there anything there connection?
No, sir.
1 to 2. 1 to 2.
Two, sir.
2. Yes, correct. So 2. 1 to 3. No direct connection, right? So we keep it infinite. 1 to 4.
6,
One.
6.
Ah,
See the arrows clearly. Okay. 2 to 1.
7,
7. Okay. 2 to 3.
two.
2 to 3 is 2. Okay. 2 to 4. No connection.
Infinite.
Infinite. Okay. Next, 3 to 1.
Five.
5. Okay. 3 to 2. No. There is no direct connection. Infinite. 3 to 4.
One.
1, sir.
1. Okay. Let me just make it like this. 4 to 1.
One.
1. 4 to 2.
Infinite.
Infinite. 4 to 3.
Infinite.
Infinite.
Infinite. Okay. So this is our adjacency matrix. So this construction indicates that there is a direct connection between 1 to 2. That means in a direction of 1 to 2 with a weight 2. And there is another direction 2 to 1 with a weight 7. So that means if you see that 2 to 3 has a weight 2 and 3 to 2 is infinite, that means there is no direct connection between them. Now, let us take something called intermediary. Intermediary in the sense from anywhere you are trying to reach any other node using the intermediary. So how we select intermediary? Let us see what are the nodes that are there with me. 1, 2, 3, 4. So I will select this one as intermediate. What this really means? For example, if you want to find out 2 to 3, if there is anything that is there, even though you have a direct connection to, we will check out if there is a connection from 2 to 1 and 1 to 3. So this is what the intermediate. If you want to find out if there is a connection between 4 to 3, we have to find out whether there is a connection between 4 to 1 and 1 to 3. Why we need to find out? Let's see. If 4 to 3 is infinite and 4 to 3 via 1 is something different. Okay, if there is something else, maybe we take an example. It is occupying 2 weight and this is 3 weight. That means you have 5, right? 4 to 1 is 2 plus 1 to 3 is 3. So naturally, you will have 5, which is less than infinite. So this will be selected, and instead of infinite here, we will rewrite it as 5. That means showing that from 4 to 2, via 1, you will have a shortest path. The next intermediary will be 2. So we will select 2 and do it. So let's see how the intermediary will be selected and what the process will go on in your Floyd Warshall all pair shortest path algorithm. Okay, let's write down. So if I call this as A0, if I call this as A0, the next matrix will be A1. A1 in the sense the first intermediary. Now let's take into consideration that we are selecting 1 as our intermediary. So this is selected now. Okay. So when you select 1 as intermediary, the row and column which is connecting to 1 should be kept intact because we want those weights should be used. So see how I am doing it. 1, 2, 3, 4. Here also 1, 2, 3, 4. So this weight, the row and the column which is connecting to 1 should be intact. So let's write down this with another color. 0, 2, infinite, 6, 7, 5, 1. So this is intact. So that means the column which is belonging to 1 and the row belonging to 1 should be kept intact. Okay. Next. Just a second. Now your turn is to find out the remaining things because all connecting directly to 3 to 1, 4 to 1 should always be having a direct one. So there is no change. I want to find out what are all the other things that we have intact. And this also remains intact because they are diagonals, right? 3, 3, 2, 2, and 4, 4. That's all. Now I want to find out 2 to 3 approach, 2 to 4 approach via 1. So let's write down how we can do it. So first of all, I want to find out 2 to 3. So I will say this is A0 of 2 comma 3 is equal to A0 of 2 comma 1 plus A0 of 1 comma 3. So this is what we need to find out. Now tell me what is A0 of 2, 3. Go to this matrix A0 and find out what is 2, 3. Tell me whether less than or equal to we have to find out. Please tell me what is A0 of 2, 3?
2.
2. Because A0 of 2, 3 means 2, 3 is 2. This is what we have selected. Coming to this, what is A0 of 2, 1?
7.
7 plus what is A0 of 1, 3?
Infinite.
Infinite. So 7 plus infinite will be infinite only. Okay. So because 2 is less than infinite, we do not change it and we keep 2 there itself. So I will write everything with this one. So we write 2 there itself. Now, what is the next one that we can find out? What is the next one? 2, 4. So let's write down the same thing. A0 of 2 comma 4, and this is, we want to find out whether less than or equal to or greater than. A0 of, tell me what should I write now? Because our intermediary is 1. A0 of what you will write? See the above one, how I written? Tell me. Write
2,
it.
1 and 1, 4, sir.
Yes, 2, 1 plus A0 of 1, 4. See, 2, 4 via 1. That is the reason. First, we need to go to 2 to 1 and then 1 to 4. We want to check whether the path is there or not. So, tell me what is A0 of 2, 4?
Infinite.
Infinite, sir.
Infinite. Okay. What is A0 of 2, 1?
7.
7. What is A0 of 1, 4?
6.
6. So, what is 7 plus 6? 13.
30.
And of course, 13 is less than infinite, right? So instead of this infinite, we take 13 and update it. So that means from 2 to 4, you have a very less distance of going via 1 to get to 13. Let us check 2 to 4. So we got 2 to 1, 7, 1 to 4, 6. That we got 13. Okay. Finished up with this. And in the next row, we want to go to 3, 2. The same thing that we have to write. A0 of 3 comma 2. That means we take the values from before and find out which one is less and which one is greater. Now tell me what should I write? A0 of
3, 1.
3, 1 plus A0 of
1, 2.
1, 2. That's correct. So what is A0 of 3, 2? See here in this
Infinite.
one. Okay, infinite. What is A0 of 3, 1?
5.
5. What is A0 of 1, 2?
2.
2. So infinite is greater than 7. So instead of infinite here, we take and replace it with the latest value 7. That means from 3 to 2 via 1, we can go with a distance of 7. Now let's take 3, 4. A0 of 3, 4 shall be written as A0 of 3, 1 plus A0 of 1, 4. So if you consider A0 of 3, 4, it will be 1. You can see here 3, 4 is 1. What is A0 of 3, 1? 5. A0 of 1, 4? 6. So which one shall I select? 5 plus 6 or 1?
1.
1. So we keep 1 like that without any change. Now coming to 4, 2. 4, 2 can be written as A0 of 4, 2 4 comma 2, a0 of 4 comma 1 plus a0 of 1 comma 2. Tell me, what is 4 comma 2? Infinite.
Infinite.
What is 4 comma 1? 1 plus 1 comma
1.
2, 2. Which one is less? 3, right? We got 3 as an answer. So instead of this infinite, we will take and replace with 3. Now 4 comma 3, tell me now what should be the answer? You calculate and tell me. In the meanwhile, I'll rub all these things. For 4 comma 3, you tell me a0 of 4 comma 3 should be compared with a0 of 4 comma 1 and 1 comma 3. So which one is the best, you tell me?
It will remain infinite, sir.
It will remain infinite. Why? The other side is also having infinite?
Yes,
Yes.
sir.
Okay, then it will be infinite.
Excuse me, sir.
Yeah, sorry.
Sir, can you just once explain why we are doing this a0 of 4 comma 1 plus a0 of 1 comma 4?
So this is a part of the algorithm that they want to find out, like all pair shortest path in the sense. See here itself in the adjacency matrix itself, you can see. Okay, let me write down first this infinite. Okay, I know that this doubt will arise. So you can say that from 1 I can reach to 1, 2, 3, 4. How much of weight it will take for me to reach all these nodes? From 2, how much of weight I can get to reach all these nodes to 1, 2, 3, 4. That means the other one. For 0, it will always be 0 because we don't have this looping. So the diagonal is always 0. Now, this matrix shows how each node is connected to all the other nodes with some weight. This matrix shows how you can modify the weight in such a way that you can approach 2 to 3 via 1. So that means, you see, from every node, I want to reach this node and find out if I can reach through 1. And in the next one also I will say that if I can reach from 2 to 4 via 3, 2 to 1 via 3. So I want to check every path. So in the dictionary algorithm, you see you only know the shortest path, but you don't know what is the path, via what you are going. So in the same sense, here what we are doing is if there is any path through something. So for example, in Visakhapatnam, if I want to go from Sitamadara to MVP, I can check whether I can go through Madilpalam or I can check I can go through Iskakota. So there are many ways I can go to MVP. So I want to check which one is the shortest one. So that is the reason why we take intermediary. So intermediary tells that to go from one node to the other node, in between you can access any node if this really allows you to go through the shortest path. I think, sorry, I answered your question.
Yes, sir. So we are trying to find the intermediary for which the path will be shortest, sir.
Yes, correct. So we target one node and we target an intermediate node to reach a targeted destination node. If this is really possible, or the direct connection is already there, which is having the less path. So in that sense, we are checking out whether we can go through that. See how many modifications will go on. So take it away. This is finished. So come to this next intermediary 2. So now we want to check all nodes connecting to all other nodes via 2. So this I will keep the name of this adjacency matrix as A2. Now tell me which one I need to freeze from A1 Which one I need to freeze? So when you are coming to A2, you need to only check A1. A0 is finished. So there is no work with A0. So I'm taking 2 as intermediary. So which one should be fixed?
Second row
Second
and
row and
second
second
column.
column.
Yes, correct. 4. So you have 1, 2, 3, 4. Okay. The fixed one should be like this. So 7, 0, 2, 13. This is the updated one we are trying to fix. And in this 2, 7, 3. The remaining are all zeros. These ones, diagonal ones. Okay. Now we have few things to be filled. What are the things that I need to fill are these things. 1, 3, 1, 4, 3, 1, 3, 4, 4, 1, 4, 3. Okay, these are the things I want to fill. So let's write down 1, 3. So now you have to take the formula. If I am at A1, I'm sorry, I am at A2, I want to go to A1. So A1 of 1, 3 should be checked with A1 of, tell me, what should I check?
1, 2
Yes, A1 of 1, 2
plus
plus
2, 3.
A1 of 2,
A1
3.
of 2, 3. Because I want to go from 1 to 3 via 2. Because this is intermediary. Now tell me what will be the answer? What is 1, 3? A1
Infinite.
of 1, 3 is infinite. Now look into this matrix. This is the latest matrix, right? What is A1 of 1, 2?
2,
2. What is A1 of 2, 3?
2.
2. So 2 plus 2, 4. And hence, 1, 3 instead of infinite, we can now update it with 4. So 1, 2, 3 via 2, we got it as 4 units we can reach it with. Next one, 1, 4. So A1 of 1, 4, A1 of 1, 2 plus A1 of 2, 4 because this is possible. Now what is A1 of 1, 4?
6,
6. What is A1 of 1, 2?
2,
2. What is A1 of 2, 4?
13.
13. So which one is greater? Is it 6 or 2 plus 13?
2 plus 13.
So we leave 6 as it is. We have 6 already. So 1 to 4 is better, not via 2. A direct connection from 1 to 4 is better because we have 6 instead of going via 2. Okay. Now coming to 3 to 1. Now tell me what should be the answer for 3 to 1 with the formula? A1 of 3, 1 should be compared with A1 of 3, comma 2 plus 2, comma 1. And based on 5, you tell me which one is the best and tell me, I will write here.
Sir, 5.
5 only. Okay, good. Now verify 3, 4. 3, 4 can be written as A1 of 3, comma 4 to be compared with A1 of 3, comma 1 plus A1 of, sorry, 3, comma 2 plus A1 of 2, comma 4. Because 2 is intermediate. You want to reach from 3 to 4 via 2. Tell me the answer.
1,
1 is only fine. Okay. Now 4, comma 1.
1.
4, comma 1 is also 1. Okay. Because not everything is less than great less than 1, right? Okay, 1. Next 4 comma 3. So 4 comma 3 should be counted with 4 comma 2 and 2 comma 3 of A1. 4
5.
comma 5. So instead of infinite, so here you see the A1's 4 comma 3 is infinite, but now we got 5. Okay, I hope this is correct. Right. So this is the latest matrix. Now take the intermediary 3. Now we have to reach from every node to every other node via 3. So this time I will keep this matrix as A3 is equal to 1, 2, 3, 4, 1, 2, 3, 4. Okay. Now what should be freezed here from A2?
Third row and third column.
Third row and third column. So 5, 7, 0, 1, 4, 2, 5. And the diagonal also, because this is always fixed. There are no loops. Now we have to find out what is the weight that I can reach for these values. Now find out 1 comma 2. So this time the formula will be A2. So you have to say, just see the previous one. So A2 is equal to, sorry, A2 of 1 comma 2 is equal to A2 of 1 comma intermediary 3, right? So 1 to 3 plus A2 of 3 to 2. So 1 to 2 via 3. So first we will go from 1 to 3 and 3 to 2. If you see 1 to 2 in A2, it is 2. What is 1 to 3? 4 plus what is 3 to 2? 7. Of course, 2 is less than whatever the total might be, that is 11. So naturally we will keep 2 there itself. Coming to 1 to 4. So A2 of 1 to 4 can be written as A2 of 1 to 3 plus A2 of 1 to 4. Sorry, 3 to 4. So 1 to 4 we can go from 1 to 3 and 3 to 4. Let's see what is 1 to 3. First of all, I want to see 1 to 4. 1 to 4 is 6. 1 to 3 is 4 plus 3 to 4 is 1. I think this is less, right? So considering 6, which is a direct connection, if 1 to 4 we want to go, we can go via 3, it seems, which is occupying only 5, right? That's correct. So because you can see here, 1 to 2, with 2 you get 2 to 3 we can get to 4, and 4 to this third node to 4 we can get to 5. That's fine. So this is the shortest path. Now just instead of 6 I will prefer 5. Now fill all these things and tell me the same way.
So 2 1 will remain 7.
Okay, just a minute. 1 will remain 7. Okay.
2
Next.
4 will be 3.
3, right? Four one. I think 4 1
1,
is
sir.
1 and it should remain 1 only because 1 is less. 4 to 2. That means we need to check 4 to 3 plus 3 to 2. I think it is better to keep only
3,
3.
sir.
Yes.
Yes. Yes. So we only keep 3. Okay. So this almost you can see that the infinite has been removed, and somewhere we are trying to go. If really infinite is there, that should be there, but we are finding out the shortest path. And final and remaining thing that we get is 4. That means reach every node to every other node via 4. And so I will give you only this time the fixed one, and you need to fill everything else. So 1, 2, 3, 4. 1, 2, 3, 4. You know now the formula is A3. A3 of I comma j. So I will write down the formula later. Just try to write down. The things that should be freezed from A3 is 5, 3, 1, 0, which is all related to 4, 1, 3, 5, 0, and the diagonals also. What are the other things that you need to find out? 2, 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2. So these are the things that you find out via this. So for 1 to 2, what you write? So 1 to 2 can be written as A3 of 1 to 2. So that means 1 comma 2 should be written as A3 of 1 comma 4 plus A3 of 4 comma 2. So like that you write down and find out the metrics. And that should be your final shortest path from all pairs. Tell me the values after you finish it. So this is the one that you do, and doing code is very easy with this. Using this formula, it's very simple for you to do because you are storing the metrics. And of course, the space complexity also the same. The space complexity is n because you are creating n number of metrics for n number of nodes. And you have to use two for loops because it's a 2D matrix, and hence the time complexity occupies n square. And that too you are going through n. So that means n square into n, that might become sometimes like n cube also.
So what if we try to use the NumPy package?
You can use for arrays. That's not a problem. The time complexity will be the same at any cost. So whether you write a raw code or you are saving your time of writing the code using NumPy package. But whatever you are doing, the underlying implementation should carry the same time complexity for this algorithm. Did you understand, Saurabh?
Yes, sir.
Okay.
So it's the matrix I have completed. It's 0
Okay.
to 4, 5.
Just let me write down. Yeah. 0 to 2 is what?
0 to 4, 5. So the first row.
Okay,
0 to
okay.
2 is
0 to 4, 5. Okay.
yes.
Second,
Then 4023.
4023. Good. So that 7 has been erased and now 4 replaced. Okay.
2401, sir.
So 5 is erased. 401. Next.
That's it.
Okay. That's it. So this is your final all pair shortest path answer. So from 1 to all other nodes, you can reach with this shortest path. From 2 to all other nodes, you can reach this shortest path. See the difference between Dijkstra and Floyd Warshall. In Dijkstra, we are only targeting one node and we are trying to reach from one node to all other nodes. But Warshall, at a time, it can capture the shortest distance from one node to all other nodes. Not only one node, but it is focusing on how all nodes can reach to all other nodes via some shortest distance. That's what this Warshall Floyd algorithm, and that is the reason why it is called all pairs shortest path algorithm. You can also note down the formula. So if you are at k, that means if you are at 4, you need to find out a3 of ij is less than or greater than or equal to a3 of ik plus a3 of kj. The k should be 4 in our case. So if you use this formula, you can also write the code easily by keeping the conditions and replacing it to the new matrix. Okay, so I hope you understand until now. So I will give you a puzzle for this again. So take the same graph which we have done for Dijkstra and find out all pair shortest path. So here we have no numbers, but still you can say if you are taking A as intermediary, you take A0, B as intermediary, A1. You follow the same methodology, but instead of numbers, you have A, B, C, D, E, F. Use this same graph and try to write down what is the matrix that you have. And in the next class, we will try to solve this problem and do it. Okay? We can just leave the class now and you can try that program until you go to the next class. And at 3 o'clock when we meet, we will discuss how we have solved this problem. Bye bye.